Ever wondered what QoS and CoS are? Today, we'll unveil the mystery. Let's start by defining these terms. QoS, or quality of service, is a collection of technologies designed to manage network traffic in a more predictable way. Its main goal is to ensure a consistent and reliable delivery of specific types of network traffic over others. In essence, it's like having a VIP lane on the highway for important traffic. QoS allows network administrators to prioritize certain types of traffic, such as voice or video, over less important types, like regular internet browsing. This ensures that the most critical data gets through even when the network is congested. For instance, imagine you're in a room full of people, all speaking at the same time. Without any way to prioritize who to listen to, it would be difficult to hear the most important messages. But if you had a system that could prioritize certain voices, maybe those that are loudest, or those that are speaking about the most critical topics, you'd be able to focus on what matters most. That's what QoS does for network traffic. On the other hand, we have CoS, or class of service. CoS is a method of managing multiple traffic profiles over a network. It does this by grouping them into classes and treating each class as a single entity. This approach provides a more efficient way to manage network traffic, as it allows for the prioritization of certain classes over others. Think of it like a school system. Each class or grade has its own set of rules and priorities. The students or network traffic within each class are treated as a single group, with the same rules applying to all. This way, the school can ensure that the most important classes, like the senior year for example, get the resources they need to succeed. In the context of networking, CoS allows for a more granular control over network traffic, enabling more efficient use of network resources and ensuring that the most critical data gets the attention it deserves. So, while QoS is the overall policy, CoS is a way of implementing that policy. Now that we understand QoS and CoS, what is the best effort model? Let's dive right into it. The best effort model is a type of network model where all data packets are treated equally. This model is often likened to a highway where all vehicles, regardless of their size or importance, share the same road and abide by the same rules. In the world of data transportation, each packet, whether it's a critical business application or a simple email, is given equal priority and access to network resources. This democratic approach might sound ideal, but it comes with its own set of challenges. For instance, since there's no class system in place, there are no guarantees about the delivery of data packets or the time it takes for a packet to reach its destination. The network does its best to deliver each packet to its end location, but there's no assurance it will arrive in a timely manner, or even at all. This can be problematic for time-sensitive or critical data that needs to be prioritized over less important traffic. Think of it as sending a letter in the mail without tracking. You drop your letter in the mailbox and hope it will reach its destination. It probably will, but there's no guarantee when it will arrive or if it will arrive at all. There's no system in place to ensure your letter gets preferential treatment over other mail in the postman's bag. In the digital world, this can have significant implications. For example, if you're streaming a video and the network is congested, the best effort model doesn't prioritize your video stream over other data, which can lead to buffering or a drop in quality. Despite these drawbacks, the best effort model is still widely used. It's simple, easy to implement, and doesn't require complex algorithms or configurations to manage data traffic. In essence, the best effort model is like sending a letter without tracking. It'll probably get there, but there's no guarantee. From a model that treats all data equally, we move to the Diff service model. But what exactly is it? Imagine a bustling city with traffic flowing in every direction. Now let's translate this image to the world of network data. The Diff service model, short for Differentiated Services Model, is like a sophisticated traffic management system for this city of data. It's a network architecture that classifies and manages network data traffic in a streamlined and efficient way. Picture this. Each piece of data, or packet, is like a vehicle on our city's roads. Some vehicles, like fire trucks or ambulances, are more critical than others and need to get to their destinations faster. Similarly, in the Diff service model, certain types of data are prioritized over others. This ensures that critical services receive the bandwidth they need to function optimally. But how does the Diff service model determine which data packets are more important? It's not a random process, but rather a classification system based on the type of service required. For instance, real-time services such as video conferencing or voice calls are often given high priority, as delays or packet loss can greatly affect their performance. On the other hand, services like email or file transfers, which can tolerate delays, are given lower priority. This doesn't mean they're ignored, but rather they're handled in a way that doesn't compromise the performance of higher priority traffic. The beauty of the Diff service model is its flexibility. The priorities can be adjusted based on the specific needs of the network, making it a versatile solution for managing diverse data traffic. To sum it up, the Diff service model doesn't treat all data equally. Instead, it acknowledges the unique needs of different data types, ensuring that each packet gets the attention it deserves, based on its importance. So, while the best effort model is a free-for-all, the Diff service model is more like a well-ordered queue. We've talked about network traffic and models, but what about the tools that manage them? Enter the Cisco Unified Communications Manager, or Cisco CUCM. This software-based tool is a key component in network management, especially when it comes to handling voice, video, messaging, and mobility products. Let's take a closer look. The Cisco CUCM is essentially a call processing component in Cisco's IP telephony products, providing services such as session management, voice, video, messaging, mobility, and even web conferencing. It's a bit like a conductor for an orchestra, ensuring all the different instruments play in harmony and deliver a unified performance. But the Cisco CUCM doesn't stop there. It's also responsible for the routing and signaling of all calls. In other words, it's the one directing traffic, deciding which route a call should take, and signaling to the devices involved when to start and stop. In the context of the quality of service and class of service models we discussed earlier, you can think of the Cisco CUCM as the entity that ensures these models are implemented effectively. For instance, in a best effort model, it would make sure that all packets have an equal chance of being delivered, regardless of their content type or importance. On the other hand, in a differentiated services model, the Cisco CUCM would be responsible for assigning different priorities to different types of traffic, ensuring that the most critical data reaches its destination first. In a nutshell, Cisco CUCM brings together all the elements of your network and ensures they work together to deliver the best possible service. It's an integral part of any modern network, helping to ensure that data flows smoothly and efficiently, no matter how complex the network or how heavy the traffic. So whether you're managing a small business network or a large enterprise system, the Cisco Unified Communications Manager is an invaluable tool, helping to keep your network running smoothly and efficiently. Think of Cisco CUCM as the traffic controller, making sure everything runs smoothly and efficiently. It's been quite a journey, hasn't it? Let's take a moment to summarize what we've learned. We kicked off our exploration with quality of service, or QoS. We learned that it's not just about providing excellent service, but it's a set of techniques to manage network resources. It's about ensuring that certain types of data get priority over others, preventing congestion, and guaranteeing a certain level of performance. Next, we dove into class of service, or CoS. It's another technique used to manage traffic on a network, but it's a bit simpler than QoS. CoS tags packets with a priority level, and routers and switches use these tags to decide which packets to deliver first. In essence, CoS is a bit like the VIP lane on a highway, ensuring that high-priority traffic gets where it needs to go quickly. Then we moved on to the best effort model. It's a simple model where all packets are treated equally, and there's no guarantee of delivery. It's like sending a letter in the mail. You hope it gets there, but there's no guarantee. It's a simple, but often insufficient way of managing network traffic. We also explored the differentiated services model, or Diff service model. This model is a step up from the best effort model, as it allows for different levels of service for different types of traffic. It's like having different lanes on a highway for different types of vehicles, ensuring that each type of traffic gets the service it needs. Lastly, we delved into Cisco Unified Communications Manager, or Cisco CUCM. It's a powerful tool that manages voice, video, messaging, and mobility services on a network. It's the conductor of a network orchestra, ensuring that every piece plays in harmony. In sum, QoS, CoS, the best effort model, the Diff service model, and Cisco CUCM are all crucial components in managing network resources. They each play different roles, but all work together to ensure smooth and efficient network operation. Remember, understanding these concepts is the first step towards mastering network management. Stay curious and keep exploring.